Hello, welcome. Let's continue to solve Leetcode problem 1136, parallel courses. We are given an integer n, so n is the number of vertices, so it is starting from 1 to n. And we are also given an array relations, so where relations I is the previous course and the next course. So representing a prerequisite relationship between course, previous course, and the next course. Yeah. So this means if we need to take the next course, we have to finish the previous course. So this is like the real life story. So in one semester, you can take as number of courses as long as you have taken all the prerequisites. Yeah. So in the previous semester for the course you are taking. So this means, so for example, in the previous semester you have courses with 1 and 2. If you finish this 1 and 2, definitely for the next semester you're gonna finish this course 3. So we're gonna return the minimum number of semesters needed to take all courses. If there's no way, we're gonna return -1. So in this example, we can first take course 1 and 2 in one semester, and in another semester we're gonna finish this course 3. So there are gonna be 2 semesters. So we're gonna return 2. Let's check the second example. In this example, we can never do that because they are independent with each other. It is a loop. Yeah, this means you can try to finish the course 1, but it is dependent on course 3. If you were to finish course 3, it's dependent on course 2. If you were to finish course 2, it's dependent on course 1. It means you can never finish one course. You have to finish them all together. Yeah. So this means this gonna never happen. If you decided to try to take one course, but it is dependent on the other courses, it means it's gonna never happen. So we're gonna return a -1. Yeah. So this means if you design a course schedule, you can never design a loop. Yeah. Now let's try to find a way of how to solve the problem. Normally for the course schedule, definitely we're gonna think about the topological sort. Yeah, because in graph we can use the topological sort to check the layers by layers until we find how many layers. So for this example, we have 2 layers. Yeah. So from the beginning, we're gonna put this 1 and 2 inside the queue, and we take it out, and we're gonna check the next layer, and we're gonna check this one. So it's gonna be 2 layers. So we're gonna return a 2. Yeah. But this is dependent on if we can finish all the courses. Yeah. But if there's a loop of the course, for example, 4, 5, 6. Yeah, for the course 4, 5, and 6, it is a loop. It means we can finish 1, 2, 3, it is okay, but we can never finish 4, 5, and 6, so we're gonna return a false. So this means we have to check how many courses we can finish as well. So if we can finish 3 courses, and if we can finish 3 courses, so definitely we're gonna finish all courses because there are only 3 courses. Yeah. So while we finishing these 3 courses, we have to check how many layers of the BFS. So there are 2 layers, so we're gonna return 2. Yeah. So but if there are 6 courses, even we finish those 2 layers, but we only get 3, but there are 6, but it should be 6. I mean 6 courses. Yeah. So we're gonna return a -1 because we can never finish all of them. Yeah. Now let's try to start coding. Normally we're gonna prepare a graph and integrate. So the graph gonna be a default dict, and with the list inside, and the integrate gonna be 0 times n. Yeah, because this is gonna be the BFS for topological sort. Now I'm gonna check all the edges. So for AB, inside the relations, so for GA should append B, and integrate with B should plus equal to 1. Yeah. Now I'm gonna prepare the queue. It's gonna be the queue, and I. So for I, they enumerate the integrate. So if this they equal to 0, so this means we're gonna put node 1 and 2 inside of the queue. Now we also need to prepare 2 other variables. It's gonna be result, so it's gonna be our final result. And basically we're gonna check how many layers, how many semesters, and we also need a counter. We need to check how many courses we've already visited. Yeah. So it's gonna be starting from 0 and 0. Now I'm gonna start the BFS. So while q not should be equal to q dot pop from the left side, I'm gonna check the neighbors. So for neighbor in G with this node, yeah. So for the integrate for this neighbor, it's gonna be minus equal to 1. So I'm gonna check the integrate. If this neighbor equal to 0, basically I need to put it inside the queue. Yeah, put the neighbor inside the queue. But currently I didn't check anything about this result and count. So from where we can count. So if there's a node pop out of the queue, definitely we're gonna count it. Yeah. So this means how many courses we've already finished. Yeah. And now we're gonna check the result. So if we want to check the result, basically we need to check layer by layer. So it means for underscore in range length of the queue, because in this way, by using BFS, we're gonna check the layers by layers. Yeah. So after checking one layer, yeah, I did something wrong. After checking one layer, so the result should plus equal to 1. It means how many layers, basically how many semesters. Yeah. Now we can try to return the final result. So we're gonna return the semester's result. So if this count equal to the number of courses equal to n, so else it means we cannot finish them. We're gonna return a -1. Yeah. Let's just check if there are any other cases. Maybe. So let's just check if there are any other cases. So for example, yeah, I think there are any other cases we need to take care, because it's labeled from 1 to n. There's no 0 cost we have to take care. Yeah. So this means it's gonna be 0. We can solve it like this: 0 plus 1. Basically, it means we're gonna start from the node 1 to 3. It is without node 0. So for here, we need to check, and I should not equal to 0, and then we're gonna put it inside the queue. So for graph, it is also okay. Let's just check other things. So if there's only one course, for example, there is only a course 1. There's no edges, and the n equal to 1. So what are we gonna return for our algorithm? So it means we're gonna never check the queue, because yeah, let's just check, because for the integrate it's gonna be 0. So we're gonna put this one inside the integrate. So there will be a node 1 inside the queue, and we're gonna check the queue. After checking this queue, we're gonna have a result plus 1. From 0 plus 1, it's gonna be 1. So we're gonna return 1, because this count gonna be equal to n. Yeah, it should be okay. Now let me just run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed all testing cases. Yeah, basically we need to be careful to analyze all cases. Yeah, otherwise it's gonna be easy problem. Yeah, I mean you have to analyze the different cases. You have to finish all the courses, and then you're gonna check how many semesters you're gonna finish. If you cannot do that, you're gonna return a -1. And the time complexity is going to be O E plus B. E is the number of edges, so let's check the number of edges. It's going to be 5,000, and the number of vertices is also 5,000. So that is why it is so fast. Thank you for watching. See you next time.